The dolphin therapy problem is an example of how simulation can be used as an introduction to inference. In the dolphin therapy experiment, researchers recruited 30 subjects aged 18 to 65 with a clinical diagnosis of mild to moderate depression. Subjects were required to discontinue use of any antidepressant drugs or psychotherapy 4 weeks prior to the experiment and throughout the experiment. These 30 subjects went to an island off the coast of Honduras where they were randomly assigned to one of two treatment groups. Both groups engaged in the same amount of swimming and snorkeling each day, but one group, the Animal Care Program, did so in the presence of bottlenose dolphins, and the other group, the Outdoor Nature Program, did not. At the end of 2 weeks, each subject's level of depression was evaluated, as it had been at the beginning of the study, and it was determined whether they showed substantial improvement, reducing their level of depression, by the end of the study. What do you think the researchers' hypothesis was when they designed this experiment? The researchers may have hypothesized that swimming with dolphins is therapeutic for patients suffering from clinical depression. What research question could we ask to test this hypothesis? We could ask, is there a difference in depression among participants in the dolphin therapy group as compared to the control group? At the end of the experiment, the researchers found that 10 of 15 subjects in the dolphin therapy group showed substantial improvement compared to 3 of 15 subjects in the control group. Find the difference between the proportion of subjects that improved in the dolphin therapy group and the proportion of subjects that improved in the control group. The difference in the two proportions is 0.47. Do these results appear to support the claim that dolphin therapy is effective? Why or why not? Some things to consider are that while it is possible that the dolphin therapy is effective, it is also possible that dolphin therapy is not more effective, and that the researchers were unlucky and happened to assign more of the subjects who were going to improve anyway into the dolphin therapy group than the control group. One way to examine this is to consider what you would likely see if 13 of the 30 people were going to improve regardless of whether they swim with dolphins or not. If that was the case, how many would you have expected on average to end up in each treatment group? If 13 of the 30 were going to improve regardless of treatment condition, we would expect on average about 6 or 7 of those subjects to end up in each treatment group. What else might have happened? Well, we could have seen that the smallest difference in the proportion of subjects who improved is 6 in one group and 7 in the other. The largest difference in the proportion of subjects who improved we could have seen is 13 in one group and 0 in the other. The key statistical question we should ask is that if there really is no difference between the therapeutic and control conditions and their effects of improvement, how unlikely is it to see a result as extreme or more extreme than the one we observed in the data just because of the random assignment process alone? How can we simulate this experiment happening again with the assumption that those who improved will always improve?
Here we have the original results from the experiment. Remember that 10 people improved in the dolphin group and 3 people improved in the control group. If we assume that the same 13 people would have gotten better regardless of the type of treatment, then we can shuffle these cards and reassign them to the 2 treatment groups, making sure to shuffle sufficiently well. Notice, this time we have 1, 2, 3, 4, 5, 6 out of 15 that got better in the dolphin group, and 1, 2, 3, 4, 5, 6, 7 that got out of 15 that got better in the control group. We can again shuffle and compare the proportion of people who got better in the dolphin group and the proportion of people who got better in the control group, again making sure to shuffle sufficiently well. This time we have 1, 2, 3, 4, 5 out of 15 that got better in the dolphin group, and 1, 2, 3, 4, 5, 6, 7, 8 out of 15 that got better in the control group. We can repeat this as many times as we like. How does this process help you get an idea of whether or not our original results were likely? How many times do you think you should shuffle and reassign in order to have enough evidence that the dolphin therapy worked or didn't work?